Hello students, in this session of trigonometry, we find the squared relations between trigo ratios, which we also call as fundamental identities. Well, in a right angle triangle, I have triangle A, B, C. This BC we mark it as A, CA we mark it as B, and AB we mark it as C. So we have from Pythagoras theorem, C square is equal to A square plus B square. Definitely C is not equal to 0. I can divide by C square. This implies A square upon C square plus B square upon C square. This is equal to 1. Now, if I take angle A, then A upon C, which is opposite upon hypotenuse, we can write down this as this for angle A. For angle A in triangle ABC, I have A is opposite side upon hypotenuse, the whole square, and B is the adjacent to the angle A. So, I get adjacent side to hypotenuse square. This is equal to 1. Now, opposite side upon hypotenuse is the sine by definition. This is equal to sine square A. Adjacent side upon hypotenuse is cos square A it is adjacent side upon hypotenuse the whole square. This is equal to 1. Now, very important in this is that we call this identity for trigo ratio as circular function. Hypotenuse will never be 0. So, this particular identity is always true. If I say circular function as y is equal to trigo x, by saying trigo x, we cover all the 6 trigonometric functions where we say y is equal to sin x, y is equal to cos x, y is equal to tan x, and I have their reciprocal functions as y is equal to cosec x, y is equal to sec x, and y is equal to cot x. Then from this and this together, well, we have sin square x plus cos square x is always equal to 1. Here, very important is that x belongs to R, that is, x can take any value. Very important. Now, we take up this particular identity and we have from this fundamental identity, sin square x plus cos square x is equal to 1, we divide by cos square x. Well, I have said divide by cos square x. Very important, before division, we must take care that cos x should not take value 0. What is the important aspect to that? Remove all the points from the domain of the cos x so that cos x doesn't become 0. Then, what will I be removing the points from? The domain, that is, when I say divide by cos square x, x should not be equal to odd multiple of pi by 2, n belonging to integer. Once this condition is satisfied, then mathematics allows me to divide by cos square x. With this, yes, we have sin square x upon cos square x plus 1, this is equal to 1 upon cos square x, which is tan square x plus 1, this is equal to sec square x. So, properly written as and remembered as 1 plus tan square x is equal to sec square x, x not equal to 2n plus 1 times pi by 2, n belonging to integers. So, this must be remembered in this form completely. Now, similarly, again, if I divide this particular equation by sin square x, okay. So, divide, say I may say this as 1, divide 1 by sin square x. Now, again, when I say divide by sin square x, I must see that sin doesn't take the value as 0. Now, when sin can be 0, remove all those points where sin can become 0 from the domain of sin x. This implies x not equal to n times pi, n belonging to integers. If you see n is equal to 0, x is equal to 0, sin x is 0. If x is equal to pi, sin x, sin pi is equal to 0. So, remove all those points and then I have 1 plus cos square x upon sin square x, this is equal to 1 upon sin square x. This implies 1 plus cos upon sin is cot, so cot square x is equal to cosec square x. Very important, when I write down this, yes, x not equal to n pi, n belonging to integers. So, this again must be remembered fully as a identity. So, when we talk about these two identities, then these are also defined as conditional identities. What is important? That there is a condition involved when I write down these two identities.